We are in every phone, in every car, in every building around the globe. We are part of the green energy transformation. There's no windmill, there's no solar panel that doesn't use the copper, the lithium, the products that we help extract. Our company dates back to the days of Alfred Nobel. Before the innovations introduced in the 1800s, blasting was about use of black powder, firing it and running for safety. The genius of Alfred Nobel was really about two things. One, managing timing, and the other, making a very dangerous chemical product, nitroglycerin, safe to handle. So with his invention of the safety cap, for the first time, you could time an explosion with use of dynamite, where people could be safely out of harm's way before starting a blast, replacing the very dangerous applications of black powder. So we very proudly, through 160 years, have been making blasting safer and something that won't put miners in harm's way, partnering with mining companies.
Since its inception, Dyno Nobel has been at the front of development for safety handling of explosives. The legacy of Alfred Nobel has been fundamental. He has kept the flame of his presence alive in all of us. This mindset has provided us an engine to keep moving forward. We never settle, we're never satisfied. Everyone wants to improve, and that is something that we have to thank Alfred for instilling that desire in all of us. We are today at the Bonge plant in France. This plant was inaugurated in 1691. With time, this plant was transformed into commercial type of manufacturing product. The black powder being the number one of the products manufactured here. Since the inception of Dyno Nobel into this business, we further developed emulsions and packaged product in this journey of safety and efficiency.
Here we are just in the pooling test area. So the principle of the test is to measure energy released by the explosives. So we put underwater at 3 meter depth 500 grams of explosives. And we initiate these explosives, and we've got at 4 meters a piezoelectric probe which measure evolution of pressure during time. And we done this test to qualify our production every 4 tons. And we can improve formulation thanks to this test to improve energy efficiency of the explosives.
So we will load the blasting machine, press here the button to request the blast. After that, we will press here to prepare the probe. And the next step, we will blast in the same time.
Behind every Dyno Nobel blast is a product that we use. My hope for Dyno Nobel is that we can continue doing what we do in a safe, sustainable and innovative way well into the future. We're regularly partnering with our customers to support their decarbonisation agendas. I'm also really proud to say that this year, we built the world's first electric mobile processing unit. This green truck will sustainably deliver explosives to our customers into the future.
The way I would describe an MPU is a delivery system for raw ingredients. So we take the raw ingredients and then it's processed through the truck and gassed at the end of the hose, and that's when it becomes explosive, that's when it becomes sensitive, right before it goes into the hole.
Dyno Nobel's mobile processing units have really changed how the industry approaches blasting. And so it's important that we have the technology on those mobile processing units to ensure that that's done safely. The other benefit is that since the explosive is manufactured right there at the mine site, you get a lot more flexibility with it, where the mobile processing unit can actually take the same precursor product and turn it into a number of different types of explosives with different energy patterns. And that lets the customer really match what the explosive is to their specific needs and their specific field conditions for the best blasting results.
So the really cool thing about our MPUs is we can take all the drill data, which shows the hard rock, the soft rock for every single hole. We custom load that through our internal software. And then I'll place the dense explosives in the harder rock and the less dense explosive in the softer rock. And then the truck will pull up, they'll type in that hole number, and every single hole will get its own custom load. So not only are we saving money just because we're putting energy where it needs to be, but we're actually breaking the rock better. And I think that makes all the difference in the end product.
We focus on practical innovation, and what that means is we're not innovating just for the sake of innovation. We're really looking at real-life problems that customers have in the field that they need to have solved. We try to partner with them very directly. When they come to us with an issue or a request, we have to lean on our field personnel as well as our own expertise to make sure that we understand what their issue actually is. Because honestly, many times the customers, they might not really understand the problem that they're having, and so that's what they're relying on us for, is to also help them with that process. And to be honest, that drives most of our innovation, simply because if one customer is having that problem, it's almost a guarantee that other customers are having the same issue. So in answering that question, there's an opportunity to innovate, to improve the mining industry as a whole.
So Dyno Nobel is a very global company, and as such, we're present in different areas of the world, and we engage with different communities. It's actually fundamental to us to invest a lot of our resources to being part of these communities. And on the other hand, we receive a lot from these communities as well.
Despite all the innovations through the last 160 years, we're not resting on our laurels. We are solving our customers' problems to be more efficient and safer. Safety is in the core of everything we do since Alfred Nobel's days. There's not one day that our many PhDs and innovators don't think on ways to make mining even safer. You wouldn't be surprised in this day and age that AI is very central in that. We are collecting data of every blast around the globe to help them get better insight on how to make their operations more productive and improve the fragmentation of their rock into their processing plants. Moving forward, Dyno Nobel is thinking about full autonomy in blasting. If we can have autonomous trucks and if we can have autonomous drills, why not you dream about a future where every step along the way of blasting can be done with no person in the line of fire? There's no blasting that is worth doing if it will put any person in harm's way.